Okay, hi everybody. Welcome to the first MCK meeting for this year. Happy New Year to everybody. I mean, it's quite late in the year already, but as we haven't spoken, have a good 2026. Today we have two interesting talks prepared. As always, at first, the code of conduct from the IPCEI-CIS. Yeah, I guess we don't have to go into details. And also NeoNephos, we extended this call as well to the NeoNephos Foundation, and we have added the antitrust policy notice in the foundation there as well. And having said that, we have two interesting talks today. We start immediately then with Project Konfidence, where Max and Sarah will talk about their project, and then we continue with Steffen, who talks about deploying OpenDesk with OCM to AirCap. Okay, with that, I'm happy to hand over to Sarah.
Thank you. And I will share our slides now. Just let me know if it works.
Yes.
Perfect. Okay, then, yeah. Thanks for having us. I'm here with my colleague Max, and we want to introduce Project Konfidence to you. If you haven't heard about it so far, it's basically a framework for delivering microservice-based SaaS apps, but I also want to give some context where it fits into the whole Apero architecture, and Max will then also give you the technical details and some insights into what we've built so far and where we're headed. And to first, as I mentioned, give you a short glimpse of where it fits in. I mean, you probably have seen this diagram somewhere detailing out the open reference architecture that we're building. And probably don't we have with the data fabric here, the cloud operating system, and then the bare metal operating system. And one of the components that you can find there is Konfidence, which is situated in the operating system part. And yeah, this is what we're going to talk about today. And I want to start basically by explaining first, what the idea behind it is and why we're building this. And for this, I want to talk first about the use case that we see, that we've also seen about, and requirements we write from that that led then to the building of Konfidence. I want to visualize it based on this diagram. So you can imagine there are different providers of SaaS software that you can see on the top that want to deliver their software to different infrastructure or platform as a service providers. What we see typically is that those SaaS software apps, they are built on a microservice basis. So mainly 12-factor apps that are running in a kind of mesh like surrounding that need to be delivered to different platforms. And why did I say deliver now? So the deployment of those apps is only really a small part that they really need to be technically deployed. But what we see is that there are a lot more requirements around the whole development and delivery process that not only affect the deployment, but also how they are delivered. And from that, we derived three main requirements that we've seen that the Konfidence also then wants to solve in the end. So the first one that we typically see is that the SaaS providers need a way to deliver their new versions of their software in a ring-based or in a progressive delivery mode, so that really the deployment process and the delivery process progresses from maybe rings or other mechanisms, small group of users or businesses or tenants, and then progressively rolling out the software further to reduce the risk when doing changes and enhance the system availability. Included in that is also that this, of course, happens zero downtime. But in Konfidence, we don't talk about zero downtime simply in having like a blue-green deployment, but really also that no active user sessions are impacted if there's, for example, a UI where they are working currently, that they are not affected by a new deployment and delivery in their daily work. The second main requirement we've seen is that feature toggle management is necessary to also progressively roll out new features, maybe also first to a small set of users and then gradually to a larger user base. And the third thing we've seen that is most important for the providers is the automation part. So all of this progressive delivery and rollout should also be highly automated so that you can roll out faster and more often to reduce the size of the increments and then also reduce the risk in the end again. So to do this ideally in a daily or even more often manner. And exactly to solve those challenges, we've built Project Konfidence. So basically a tool chain to manage efficient microservice delivery. And the good thing about the project is that we don't have to start from scratch, basically. So we already have extensive experience in SAP in building microservice-based SaaS applications. So there are a lot of applications already being built at SAP. And we have built such a delivery tool chain already, purely internally, which is called Deploy with Konfidence. And with Deploy with Konfidence internally, we already support 50 plus business applications in their development, deployment, and delivery process. And basically, it's kind of the standard for lifecycle of microservice-based apps on BTP. That's why there came then the idea at some point to also open source what we've done there and donate it to the NeoNephos Foundation. The thing is that we have to change a lot of things. So we mainly rely on the concepts that we have in DWC. We don't use technically everything, but rather rely on the concepts and now do it in a new fashion, Kubernetes native and so on. But Max can go more into detail with that. And want to, now basically introduce this new project. And the main, as I already mentioned, the requirements that we want to tackle with Konfidence, here's what the main selling points are that we want to achieve. So the first thing goes into the direction of automation of delivery, as I mentioned it already. So already internally, the teams at SAP also measure their DORA metrics. And with our toolset, so also in the future with Konfidence, you will be able to improve in your DORA metrics by deploying more faster and more times, even daily or more, by a complete automation of this delivery process. Part of this automation is also that you can gain confidence in releasing. So you can qualify specific software versions, and these software versions are then stored in an immutable manner so that you can always be confident that this version that you've qualified, if it's successful, it will also work in new deployments. As I also mentioned, the zero downtime part, so that we have an atomic switch when the software version is ready, and through the feature toggles and through zero downtime, we can also control when users will get this new version then. We talk about large-scale applications that we now also implement in Konfidence. Is that implement an artifact reuse. So we're service different we reuse it. We use the TCO for the project in total. Or introduction, and I would then hand over to Max, who will go into the more detailed concepts and technical details and architecture.
I can take off screen. So in my slides now. Okay, I will introduce some of the core concepts, and afterwards about the architecture, and I will give some of what we have built so far. First, terms of use are not really confidence specific, but so that we're all talking about the same things, I want to mention them here. So in Konfidence, when we talk about software artifacts, we refer to something. We refer to the result of the work of a developer. So to help we can also say refer to something, the output of a build pipeline, and also including the configuration, which is product specific, like feature toggles. Sarah mentioned that, and translations and stuff like that. Also refer to an entire Kubernetes cluster as a namespace, as a landscape, and a landscape has one or more stages. And the important thing is that in Konfidence, a landscape is something physical, something where we can deploy to. So a Kubernetes namespace there we can deploy to, as opposed to a stage. A stage is more like a virtual thing in Konfidence. As a logical grouping, so to say. And a stage can we can assign vectors to a stage. A specific thing. It's the central concept in Konfidence is the vector. It's a mutable set of versionized software artifacts, including their configuration. And basically it describes the entire desired state of your application. And the vector can be, this is an important thing I will come to in a minute. I just want to explain what a vector this before. A vector deployment is a vector whatever to a Kubernetes namespace, for example. And then we have the concept of a promotion, which describes the action of moving a vector from one stage to another, whereby during the vector stays unchanged, so it remains the same. It's immutable, as I said. The diagram on the right side shows two vectors on the bottom. Each of them has two artifacts, and the development stage points to that slightly newer vector with this update through service, whereas the production stage points to an vector. Sorry for that. And both stages are in a Kubernetes namespace or in a Kubernetes cluster. So now let's take a look at more example. This diagram called stage-based delivery flow. So we have 3 Kubernetes clusters and 4 stages, and the initializations like that, all of these just point to the same vector. So the same version of your application is deployed in all of these landscapes. So now we can continue in stage the creation of new. We change to your creation of a new vector. So the new development in your test landscapes, and at some point you decide, now this looks good to production. This is the point where you start the promotion flow to your production landscape. First promotion which is executed is the one from your development test landscape. Run all kind of whatever test you want. You can run security scans and other validations. Lots of these tests and validations are marked, and then you can start promoting it to your production landscape. But there, before we make this new version accessible to your customers, you can deploy by you or by some internal test. and if that any last so to say, and customers have access to. And in a daily on a daily basis. So they have this entire process automated, and gain the confidence this process works, and then we can and improve the metrics there. If you look at the promotion flow, you might ask the question, or you might notice that we have 2 versions of your application deployed in the production landscape. And this might raise the question if this is not a huge range of resources, because you have your entire application deployed twice. And in theory, this is correct, but this is not what Konfidence is doing. For this, let's look at this diagram, which shows how we instrument the routing in the landscape to achieve something which we call the artifact reuse. So the initial situation here is that the customer is assigned to a production stage, and the production stage points to a vector. And previously, in Kubernetes, we instrument the gateway, the Kubernetes gateway API for this. So that requests from your customer are routed to the vector deployment. So the vector deployment, which belongs to that vector of the current version, which is assigned to that stage. So if when your developers doing their work, so they push new code changes, a new vector is created. And what Konfidence is now doing, it calculates the difference between these 2 vectors. So in this simple case, the vector differs in the version of the foo service, but it shares the same version of the bar service. And the vector deployment, which is now created for the new vector, is just deploys the missing piece, so the missing foo service, but it shares the same version of the bar service, which is already deployed for the previous deployment. And the final step of the promotion I just mentioned before is then just the switch of the traffic. We reconfigure the gateway API resources on the stuff. Now traffic from where your customers is routed to the new vector deployment. This might seem, I mean, you might think there is not much benefit of having this one service which is shared and you don't have to deploy twice there. But if you think about that, we are targeting, as Sarah mentioned, large-scale enterprise applications with hundreds of microservices. This will be a crucial benefit because if you deploy daily to your production cluster between your vectors, and then you only deploy like the small changes you have there, and can have multiple versions in your production landscapes with a small TCO. Okay, so now let's get more technical and look at split into control planes. On the left side, we have the global control plane. The name is not yet final, but so we need a name for it. So we called it global control plane, which is responsible for the vector creation. And on the right side, we have the landscape control plane, which is responsible for the vector lifecycle and for the management of the landscapes. So the vector creation basically consists of the assembly of a vector, so building a vector and pushing it to an OCI registry. We are here using the open component model as a descriptor format to describe the vector and push it to the OCI registry. And the second thing which we are doing during the vector creation, or which is part of the vector creation, is the vector promotion. So the assignment of a vector to a stage. And the stage is in Konfidence a Kubernetes custom resource. And this is one of the first two touch points we have here with the local control, with the landscape control plane. We are synchronizing this the stage custom resource to the landscape control plane with KCP. KCP is also a project of IPCEI-CIS. It's implemented by Kubernetes. And basically, it's not important that you know the details, how it works, but basically you can sync custom resources from one Kubernetes API server to another Kubernetes API server. And in the landscape control plane, when this synchronization is done, our controller recognize that there is a change in the stage custom resource. It will pull the new vector from the OCI registry, and then it will do the vector lifecycle in the landscape, which consists of the deployment. So we deploy the Helm charts, the artifacts which are part of that vector. Then we execute some migrations, for example, database migrations. And the final thing is that we activate the vector, which is this traffic which I was talking before. So this diagram is basically the same as the previous one. It just focuses on the landscape control plane because that is what we have built so far. The global control plane is not yet ready, so we are just started implementing it, but we do not have a functional version of it. The landscape control plane, we have at least a first version of it, which I will also demonstrate in a minute in the live demo. So I wanted to talk about the architecture drivers, which lead to that architecture we see here. So the first one is quite obvious. We wanted to be Kubernetes native. So we implemented all controllers which we implemented are Kubernetes controllers built with the KubeBuilder framework. And we modeled all entities and concepts which we have in Konfidence. We modeled them as Kubernetes custom resources. And so this controllers here in this box are the controllers which we implemented so far, and they are reconciling the Kubernetes, the custom resources which we have designed. The second thing is that we wanted to be sovereign by design, which means so we have this architecture which is split into control planes, and these control planes only have two touch points. The first touch point is the OCI registry, where we push and pull the vectors from, and the second touch point is the mechanism of DSP. But this is purely a pull-based mechanism from the landscape control plane. So we do not push something from the global control plane down to the landscape control plane. It's the other way around. And in FreeOV, we can totally cut out the global control plane, which is actually what we are doing, or what I will do in a minute in the live demo, because I do not have a functional version of this global control plane yet. But I just have to push a vector in OCI format to the OCI registry, and I have to define a stage which is referencing that vector, and we are good. So in theory, we can operate this landscape control plane in a private cloud, and usually the assembly integration of the but then just the third thing is that we wanted to integrate third-party tooling where possible. So the mention is that we as a vector description, for example, Flux to of the Konfidence-specific CRDs into the Flux-specific CRDs. So in Flux Helm releases, if you're aware of that, and then Flux can deploy these to the target landscape, to the target cluster. And the other third-party tooling which we integrated, I want to mention here, is the Kubernetes Gateway API. I already mentioned that we are using it to instrument the routing in your cluster. And so we are just creating Kubernetes API resources, and then you can use whatever implementation you want, you like. So for example, you can use Istio, which implements this Gateway API, and then Istio is doing the routing in your cluster. The last thing I want to mention here is that we designed this that it is extensible. We're targeting large enterprise scale applications, and I mean, we are working in SAP. We know that the big companies have their own processes, have their own requirements. So it's unlikely, or it's not possible to build a framework which you can take off the shelf and just use it. So we know that there will be requirements that you extend or adjust some points or some things about Konfidence. And one example for this extensibility is that which deploy to Kubernetes. Example project, which they case they are kind of lazy. And if we have this product page, which is basically the entry point of the application. This and the second the second vector updates the review service to version 2, and it adds another service, the rating service. And the third vector then also shares the first two artifacts and updates the second, these last two artifacts to a newer version. Okay. So let's jump into before we look at the web page of this book info application, let's talk about the vector itself. So a vector is basically it's described with the open component model. It's an open component descriptor, and here this is example. This is an example for such a vector. Let's take this example. This is the first vector from the slide. It just consists of these three artifacts in the version 1. And what we are doing here, we're referencing to another open component descriptor, which is then the descriptor of the artifact itself. So we are like combining different open component model descriptors into a vector. And if we now look at the second vector, it's just adds, or it updates the version of this review service, and it added this rating service. So we can now have a look at the CRD, at the stage CRD, which brings the stage and the vector together. A CRD is the custom resource of a CRD is really simple. It just has a name which has no technical background yet. And it's a pointer to a vector, and it's just a pointer to the OCI registry, where this vector, I previously pushed these vectors into an OCI registry, and here I can reference it. And we can now have a look at a Kubernetes cluster where I deployed already the landscape control plane controllers. So this example Kubernetes cluster consists of both. So it's the landscape control plane, so the Konfidence controllers, but also it is the landscape itself. The landscape itself is just another namespace. And I already applied here this first stage, and we can have a look at what got deployed there. So we have 3 services deployed. Ignore this MySQL service. This is something which would be deployed statically to mimic a database. But these 2 services are the services which you saw are part of the vector. And now we can access that application. It's really simple. So it's just a book info application where you have some details about the book, and you have a review section where you can see which service or which pod in this case served this response here. So if we now create a second stage, which refers to the second vector. So there is a difference. This is a new vector here, the vector with the updated review service and the added rating service. If I now apply that, we will see that there was another stage created, and in a couple of seconds, the new pods will spawn up here. Hopefully, if nobody destroyed the example cluster. Okay, there are the new pods. What we have seen here, that is 2 pods got deployed. The rating service, because this was the service which is entirely new, and the review service in this updated version. We already have seen here the artifact reuse, because both vectors now share the details service in the first version and the product page service. And basically, both versions of these applications are now deployed in our example cluster. And I can steer now with a header which version I want to consume. So currently, I have set the vector header to the first vector. That's the reason why we see this response here. If I now change that to the newly created vector, and do the request again, we will see, you should pay attention to this section here. We will see that we added the rating service, and the rating service provides now a star rating for this book. We can also see that this request was now served by another pod. And if I change that header back to the previous one, we can see that this star rating is gone. I can now deploy a third vector, which basically adds another feature. So this third vector also contains a database migration. That's the reason why we have this MySQL stuff deployed. But for the sake of this presentation, or the sake of this demonstration, this is not really important. What we can see is, so we have a third stage here. We also get the pods deployed, which are not yet deployed, which are different compared to the previous vectors. So in this case, we have a new review service, and everything else is shared. No, we have a new rating service and a new review service. So except these 2, everything else is shared. And I can now change that header again to the third vector. And if I do that request now, I will get that star rating, but now it's colored in another color. It's just an example application that you get a concept. Yes, that's basically what I wanted to show. I Yeah, I will hand over to Sarah. Back to Sarah.
Thank you, Max. So yeah, I hope this gave you a good introduction to what we are doing with Project Confidence. And basically, we're now also through with the content part. I will just quickly share the last links so that you can also know where to get up to date if something new happens. So we have this page currently hosted with not so much information, but there we will definitely also release information when we will go open source. So, and here are the links also where you can find more information. So it's confidence.cloud if you need any more info or want to follow our journey. So thank you very much. And then I guess back to you, Jan.
Yeah, thanks a lot. Maybe we have time for one question. It was really interesting to see what you have showed. Let's do one question, and then if questions are there still, please continue in the chat. Do we have a question in the audience? Okay, then I would say, Steffen, hand over back to you and for the next talk.
Thank you very much. Okay, so hello everyone. Thank you for having me. My name is Steffen Kelch, and today I'm going to show you Open Component Model, which you might have heard also in the last presentation a little bit of OCM. So software delivery, let's make software delivery simple and secure because it can become quite complex. And first, I will really give you a very rough overview and intro into OCM, and then we will deep dive very steep and very quickly into the technical details on how we OCMified OpenDesk. So in order really to run your business app or service, we really need to deploy our cluster stack and all of our applications and service components. So you definitely have somewhere, probably Git code repository, which includes your application or service, and also which includes your Kubernetes manifest or packages like Customize, Helm, or whatnot. And somewhere else, you also have your infrastructure dependencies like ISIO or the Cert Manager, or you want to have a database. And of course, we need to think about orchestration tooling like day 2 Kubernetes operator or day 2 operations overall. But how can we now ship that? How can we deploy that? And there, of course, we are using OCM to package, scan, ship, deploy, and scale out all of the software components to achieve full transparency and confidence. What a coincidence with the deploy with confidence before. So no matter where and how often and when we want to deploy our landscapes, we can do that with OCM. Now, the first step, of course, is to package your application or service into OCM components. You can use the OCM tooling like the OCM CLI or GitHub Actions or other available tooling. How does this look like? You already saw that in our last presentation here. So this is a very easy to understand OCM constructor. First, we have here the name of the component, then we have the version, and down here we are defining our resources, in which version, which type, and how OCM can actually access it. And of course, we can put a lot of here, and I will also show you later on. Then we can scan those components that we have. And therefore, we have the Open Delivery Gear. And Philip Heil, who is also in this call, he is the absolute right man to contact if you want to know how Open Delivery Gear works, because it's quite magic. So with Open Delivery Gear, we can really look into our OCM artifacts and look what is in there, and then Open Delivery Gear will scan that and check all the artifacts for vulnerabilities licensing issues, intellectual property risk, and malware as a whole. So we continuously check asynchronously even after our components have been released. This improves, of course, security and product standards compliance. And, you know, at SAP, we have a lot of those. So now it's time to ship them. We can ship it to any region, any data center. And again, the shipping is done via the OCM tooling, like the OCM CLI or the GitHub Actions. So we are supporting public, private, and sovereign clouds, and even air-gapped environments. So OCM really offers for us a standardized way of shipment for all of our SAP products and delivery channel, and hopefully soon for yours as well. Now, let's get into the nitty-gritty stuff. So how can we deploy that? Because we now have everything packaged into our OCM. And now how can we achieve our target? So for that, we have our OCM deployer. I will give you in the demo, I will show you 2 OCM Kubernetes deployers, and we'll talk about the other ones later on. So with that, we can deploy aggregated components as a whole without really taking care about the bits and pieces. We can even subscribe to our component and automate the deployments and upgrade to new services. So this really streamlines our application service deployments to Kubernetes itself. Now, how does a deployment roughly looks like? This is now an example for the Kubernetes OCM Kubernetes toolkit with Crow and with Flux. But I will also show you in the demo a second OCM aware Kubernetes deployer, which is open source. So with the kind repository, we are telling the Kubernetes toolkit where is actually, in which registry is our OCM artifact hosted. With a component, we are telling which to which component name and in which version we would like to access it. And with the kind resource, we are pointing to the name of the resource. We want to get really the actual location, because when you're shipping something, it does not mean that it resides, the content of your resources does not reside in the actual OCI registry where you have pushed your OCM artifacts. It can also just reference to, for example, NPM storage or a S3 bucket or a GitHub or another OCI repository, for example. So with this, we are getting the real information, where is this actually located in. And with the kind deployer, this is to bootstrap, to kick off the initial deployment itself. The OCM Kubernetes toolkit then applies the already rendered Kubernetes manifest that is then within the referent resources. Now, with that, all of that, we can really scale out. We can build different OCM packages for different stages, and we can deploy it anytime, anywhere we want. So this enables really to orchestrate our service deployments and enable our DevOps team to easily adopt deployments to different landscapes. An OCM-based tool chain offers really a high level of orchestration of service deployments and their dependencies within our landscape. Of course, you can also package your configuration and also your deployment templates into your components to make it even more and easy for your DevOps team or your consumers to really spin up all of your all of your packaged services and applications itself. So now to recap that, let's say, technical relationships of OCM as a whole. So there is the open source specification of OCM. So everything that you saw in here with the OCM constructor, also the scripter, which I will show you in the demo, this is all specified in the open source specification. And the OCM CLI, the GitHub Actions, and so on, those in order to model, package, and transport via the OCM, this implements the specification itself. The same on the deployer side. So as I mentioned, we have the OCM Kubernetes toolkit, which comes, which I will show you in conjunction with Flux and Crow.run, but you can exchange those with anything you want and with a landscaper. And those Kubernetes deployer are also just implementing the specification itself. And of course, the tooling is pushing, after packaging, pushing it to our OCI repository, and then the deployers are consuming from it. On top of all of that, we have the open delivery gear. So shout out again to Philipp Heil. He's the man for you if you want to know more about that. With the open delivery gear, this scans really all the OCM artifacts that are in our OCI repository, rates it, and can even do promoting. But wait, let's wait. If we do not have any functionality on the tooling side or on the deployer side, how can you help yourself? First of all, of course, it's open source. So contributions, very, very welcome. Please help us, please join us. And OCM also has a plugin system on the tooling side. And on the deployer side, of course, if it does not fit your needs, because there can be quite complex deployment scenarios out there, you can also easily build your own custom deploy, also your own custom tooling, because all you need to do is just implement the specification, and then you're free to go, and everything can work with each other. Good. So to recap, the key takeaways is really that we have now a software bill of delivery, which is the source of truth for all of our lifecycle operations. With OCM also, which I will show you in a sec, we can package, scan, ship, deploy, and scale out all of our software in full transparency and confidence. And now let's go to the demo. Let me just share my screen. Okay. And let me go to it. So the two GitHub repositories, which I will show you, they are already open sourced and public, so feel free to look at them. I will post the URLs into the chat in a second. So first of all, we have the landscaper, which is also open sourced, and the OCM Aware Kubernetes deploy, and we have the OCM Kubernetes toolkit. First, I will show you how we OCMified OpenDesk with the landscaper, and then with the Kubernetes toolkit. The technology stack is quite easy. We have our GitHub here and repository. We are running some GitHub workflows, which is doing the packaging and transporting. We are transporting then the OCM artifacts into our OCI artifactory. Then on a managed control plane, we have run our landscaper. Of course, you can just install the landscaper on the Kubernetes cluster of your choice and also do that. So you do not need the open managed control plane, but it doesn't hurt, to be honest. And the landscaper then consumes and fetches the OCM artifacts and then deploys it into our workload cluster. For that, at SAP, we have sub-cloud infrastructure, but again, you can also use any Kubernetes cluster of your liking for that. To kick that off, we have here our OCM constructor. Here you see our component name, and with that you also see one of the nice features. We have a string replacement here, so during packaging time, this is substituted with a variable you can inject during the packaging. Here you see we have a couple of resources, but as you might also know, OpenDesk is quite big, it's very, very big. So we first have our resource with blueprint, which is just a dir, and we have some Helm charts here, which is our cluster stack. And then we have a lot of component references down here. Then looking at one of those other OCM constructors in which we referenced here. So this is, for example, the element, and we have also quite a lot of other OCM constructors here. So this is very nice and neat because now you can slice and dice all of your software that you're needing for your application or for your service, and then reuse this, for example, for another software product. So slice and dicing here is very of the essence when you want to reuse it later on. Here you also see we have here the Helm charts pointing to the Helm chart, pointing to the images that the Helm chart itself is needing in order to run that. And this is quite a lot. So after packaging it, this looks like something like this here. So we have just one component here in our root component, and with -r, -recursive, we can then have a look at all the other component references that we have made. And here you already see the component references, in which version and of what provider and reference path. But now, to be honest, the resources are a little bit more interesting. The resources of our base package is really not that big or not that interesting, but when we are looking at all of the resources, we will get in a second quite a big tree. So here you see all the sub references, also with the Helm chart, with the OCI image that we have now packaged. And just with one command, I could download all of those and also the content, even if it's referenced, to my local hard drive. This would be quite big. So I would have a couple of hundreds or a couple of gigabytes on my local hard drive. I could push those then to a USB stick, ship it to an air-gapped environment, and then with the OCM CLI on that computer in the air-gapped environment, I would be able to then deploy and push it, all of those references that are now by value on that USB stick into the air-gapped environment and use it there, which is very neat and very nice. Good. Now, going a little bit more deeper into the deployment. Now, because now we have packaged and transported the OpenDesk into our OCI registry, we have so-called, this is something landscaper specific, a blueprint, and in this we are saying, okay, get me this Helm chart out of these resources, which he takes out of the OCM artifact itself and the component and the resource itself. And here, and those names you might also remember. And yeah, so this goes quite on because OpenDesk is quite big. I think it has 45 or more Helm charts itself, which needs to be done in a certain order. We can also say depends on. So this is how the landscaper is doing that. And of course, we have here a new release because also the sample repository comes with GitHub Action, which also helps you versioning all of that, so that new OCM artifacts with versions will then be pushed to your OCI registry. Good. Now let's have a look at the Kubernetes cluster itself. Here, no, this is not here. So we are now on our managed control plane where a landscaper is looking at or is running at. Again, you do not need a managed control plane or open managed control plane to do that. You can just use a normal Kubernetes cluster, which fulfills the requirement for landscaper, and then use that. So we have here the We have here all of our CRDs, and we have the installation for that. And going into that, this is our root installation, which then tells basically in which resource is our blueprint laying in. The blueprint is something landscaper specific. So because the landscaper itself is OCM aware, it can just unpackage it and then use this as a deployment template to bootstrap and to kick off the whole installation. And as you can also see here, we have a reference to which component, which version, and then within the deployment template, everything else with the deploy item you just saw, the landscaper will then work on that. And with that, we have also the deploy items here, which are all successfully installed. Good. Let's move on to the next sample. So this now here, this OpenDesk OCMification is now done with the OCM Kubernetes toolkit. This is mainly also a bit similar. So we have our GitHub repository in which we there are a couple of more GitHub workflows because the landscaper itself, it supports Go templating at deploy runtime. This functionality we do not have in the OCM Kubernetes toolkit with Flux and with Crow. So therefore we need to, because OpenDesk is heavily using the Helm files and is using that for really concatenating and then templating all of the values for the Helm charts. We need to do this beforehand and not at deploy time. So we have here the workflow, which is generating the Helm values, templating, and then triggers our package and transport of the OCM workflow, and also includes all of that into our OCM artifact itself. Now it pushes to our artifactory, to our OCI artifactory repository, and here on our workload cluster, which is currently the SAP Cloud Infrastructure, but again, you can use any Kubernetes cluster which just fulfills the requirements for having installed OpenDesk and Crow and OCM Kubernetes Toolkit and Flux. You can do that also. So on this workload cluster, we have Flux, we have the OCM Kubernetes Toolkit, and we have Crow running. And with that, with the initial Kubernetes manifest, we are then telling OCM Kubernetes Toolkit what to do, and it instructs via Crow to create Flux manifest, and then Flux is pulling out the information and installing that. And again, if you do not need to use Crow or Flux in here. So you can use and substitute those tooling with any toolings of your choice. But because the landscaper has already those kind of functionality already built in the last sample, we did not need to have Crow and Flux or Argo City or Crossplane, XRDs and so on, having deployed at our workload cluster. So this is just an example. This is just a suggestion from the OCM team, from us to you, but you can exchange it with anything else you want to have. So let's look into also the OCM constructors here. Those are looking pretty similar, to be honest. Here is we just have another blob there, which then contains all of the Helm files that have been templated and put into that. And then we have again the Nginx ingress, the cert manager, and also the configs maps, and also here the references. So basically, this is also nearly one-to-one the same, just the root was a little bit different. And because to have a dedicated standalone example, we have put those OCM constructors here. Again, normally you could just reuse the reference that we have built one time. Now, we are going into the bootstrapping. The bootstrapping is also quite simple, as I showed you before. Here we are pointing to where is our OCM artifact actually lying. Here is which is our base component, which version do we want, and then in which of those resources is really the deployment template actually about. And with the deployer, we then are installing and we are telling OCM all the Kubernetes manifests that are within those resources packaged into that, just apply them on our Kubernetes cluster. And with that, we are bootstrapping everything. Then in our bootstrap, we have Crow inside. So why Crow itself? Crow gives us the ability to define during runtime really custom resource definitions. Like here we have the kind of open desk instances with all of the components. And down here we can then say when this resource when it has we are telling him, okay, create this resource here with kind resource from the OCM Kubernetes toolkit and reference our component and which resource we want and give us the information. Then with the OCI repository from Flux, we are then parsing out, we are extracting from this resource here the registry and the repository information, and then Crow creates for Flux to understand on which OCI repository the actual content of our first Helm chart is located at. And then with the customize, it's a customize, it's not a Helm chart. With customize, we then tell, okay, from this OCI registry, apply me this this customize template and template it. The same is here with the Nginx ingress. This is the last example I will just go over it. Here we see we have the Helm repository because it's a Helm chart. And with that, we are instructing, so all of the landscaper deploy items that you saw earlier, which was the deployment template for the landscaper, we have here as the Crow resource graph definition itself. And with that, we then just create an open desk instance on the cluster on which Crow is running and or is watching, and we are telling him install this or that on this cluster. Let's have a quick look at it. Here we are on our cluster. We have the open desk instance, and we have the Crow resource graph definition looking into the instance itself. I'm using the COD wizard, which is, to be honest, quite nice. We have here the components. So what I just modeled in Crow, in the YAML, you see here live on our Kubernetes cluster, which is quite nice. Jumping back and going into the instance itself, you also see down here the conditions, and this is also via Crow. This is also highly customizable, and you can also put into the status whatever you want. So this is really the glue. Crow is the glue between the OCM Kubernetes toolkit, which exposes the information where the actual OCM artifact resource content is located at. And Crow then takes this information and puts it into and creates Flux Kubernetes manifests in order for Flux then to know, hey, there is my actual content, my Helm chart, my customize, whatnot, and I'm going to install all of that. So we have Crow, we have OCM Kubernetes toolkit. Let's have a look. Here are all the resources that now have been created by Crow, and Helm repositories, these are the Helm repositories, and OCI repositories, these are the OCI repositories that have been created by Crow to instruct Flux what to install. And last but not least, what I wanted to show you, I have forgotten that. Bootstrapping. Okay, I do not know it anymore what I wanted to show you. But anyway, this is it from my side. Let's jump back into the, oh, wait, here is also a proof that it has been actually installed. So we have all the applications running here with OpenDesk. So this one here is OpenDesk OCM. This is one, I think, with the Landscaper, and this is one with Crow. So both is working as intended. And if you have any new Helm charts or any new versions, you can then use Renovate in order to update the OCM constructors. And then the GitHub workflows are rerunning just again, packaging everything. And then, yeah, you can deploy them into your Kubernetes cluster. Good. Then, with that said, I just still have a couple of slides. 1 second, please. Okay. Okay. So this concludes now the demo. So everyone out there, so please, you're most welcome to join the OCM community call itself. It is on every first Wednesday of the month. You'll also find all of that information at the OCM community page. So please just feel free to join, to subscribe. We'll also reach out at the Slack channel, at the Kubernetes Slack. I think it's Open Component Model. Everybody's welcome. There are no stupid questions. I also ask a lot of stupid questions when going into OCM and all the other stuff that I'm working with. So no worries. Everybody there is very friendly, and you are very, very welcome. And with that, have any feedbacks, questions, let's stay in touch. Please mail me, join the community call, join the Slack channel. And with that, I'm done. Thanks a lot.
Thank you very much, Stefan. I guess we have some time left if there are any questions.
And thanks again to Vasu, who put me through all of that to do that.
Yeah, thank you, Stefan. Actually, this is Vasu. Hi there. I don't have a question, but I have an interesting remark, because what you essentially are seeing here is that the versatility of OCM depends on how you want to use it. If you have a ready off-the-shelf product like OpenDesk, you can essentially use the two sample deployment options, Landscaper, an older version, or the newer OCM toolkit, to repackage it and, or not repackage, but package more or less, and shift left the deployment techniques, and shift left in the sense of checking the security compliance and so on, but shift left that essentially the DevOps part can be delivered by an intermediary of the off-the-shelf product into an automated posture. That means your customers or the customers of this OCM toolkit would not need to read the documentation of how to install all the 100 Helm files, but they can just reuse the product DevOps model that Stefan just invented. But my comment was more also because we earlier saw the Konfidence example, and this rightly connects, because if you are shifting left even more, the Konfidence deployment options that you've seen is essentially also a very opinionated way of deploying artifacts. And this means you are not only shifting left to a off-the-shelf product, but you're shifting left directly into the development work stream. And even that can be shipped. So yeah, I found these two topics well connected. Thank you for that. That's my comment.
Thanks, Vasu.
You're welcome.
Do we have any question in the audience? Come on, don't let Steffen from the hook. I mean,
this is all the technical detail I know. So
there is a question in the chat. Okay, but are you all using Copilot to assist coding or to use Claude?
As every big company, we are looking into that. There's a lot of compliancy and guidance to that. So, yeah.
All right.
Actually,
So
I do have a comment on the use of AI. We actually have adopters of OCM using Claude to automatically generate OCM components. It's the Arc Defense Cloud. Let me see if I can find very quickly the link.
Okay, thank you very much.
all right. So Vasu, if you find the link, just post it in the chat.
Will do.
Yeah. With that, thanks for the attendance. Thanks for Steffen, to you. I don't know if Max is still there. Thanks, Max. And yeah, I will say we will prepare the samely interesting meeting next time as well, and for February, and looking forward to a big contribution again there, participation there. And with that, thanks. Have a good rest of the week, and talk to you later.